Okay, this is a quick video to have a look at one of MERG's pocket money projects. They're designed by Davy Dick of the West of Scotland area group of MERG, and he designed them to be something simple that you could put and use on your model railway layout, and for a few bucks you could build something that was really useful. And it's been a big success. The one we're looking at is Pocket Money Kit number 9. It's designed to run an intersection, a crossway, a set of traffic lights. The picture on that diagram is what you get if you build the kit exactly as it comes. And you can see it takes 12 volts in on the left hand side. On the right hand side you've got a 12 volt rail at the top, and then you have a line out for red, amber, green, then red, amber, green again. So set 1 and set 2 directly above each other. There's a set of links over this side on the board, and the links, I'll just pick this up and see if I can get it a bit closer. Okay, so the links are there to adjust the way the module behaves. So in this case, the 3 links that it lists, link 1, link 2, link 3, are about how fast it runs. So there's speed ranges there that go 5 seconds, 15, 30, 60, right up to 180. The 5 second one is useful when you first build it. You plug it together and you see if it works. It's nowhere near realistic, but then you just drive it out to how slow do you want it to go. The board has resistors at the end here that are meant to be used to be suitable for all of the LEDs that you connect in series out off each of these banks. To show that, I'll just show you the last page of this diagram. There it is there. So you can see the 2 sets again here. You can see the resistors. And you can see that the resistor here, the output here, is driving this resistor, and it's going in series through all these LEDs. When I was building this kit, I was conscious of building this as a demonstration kit for MERG members in our area group. So I wanted to build it a little bit differently with a little bit more flexibility, and not have to join up 4 masks to do it, or just 1 mask and people be left going, oh well, what if I want to change how many masks, what do I have to do with the resistors? So I've built one that's got a few more components on it, which is usual for me. So there's components on there that mean that I can't, if I connect it up to power the wrong way around, it won't die. And I've used a slightly different regulator, and I've used jumpers instead of the links so that I can change the mode this thing operates in without having to solder and unsolder links. So here's what it looks like. It's quite small because this is actually the board that the original one comes on, but I've obviously hacked around the way it's laid out and the components that are on there to get to this. And I put a screw connector on so that I can, whatever power is available at our meetings, I can just screw it on to those connectors and away we go. Down this end, you'll see I've changed the output in 2 ways. There's no resistors there, and I've moved these 3 outputs up higher, and I've brought another 12 volt line up into the middle. The reason I did that is shown here. I've color coded the outputs. So the purples are 12 volts, the reds for each bank, the yellows are the yellows for each bank, and the greens are the greens for each bank. So what it means is if I build a mast module, connect this to a mast, then the wiring I use for the first bank is exactly the same as the wiring I use for a second bank. The other thing that occurred to me was if I put the resistors out on what I'll call a headboard, then what I end up with is I'm in a position where I can add masts and delete masts as I like, so long as I've got jumpers on, or at least another set of outputs on the boards that I connect. So here's an example of one of those boards. Now obviously on a real model railway you'd have the LEDs up in a set of traffic lights up on the top. But on this board, and this is called an experiment board, they don't have the usual copper tracks underneath like you used to, so they're all individual holes. So you have to do a bit of a mess and make your own links, but we don't care. This is a demonstration of how it works, and not here, do this. So now all I have to do, and I'll show you these inputs and outputs here. What I've used is some coloured headers. So I've got a bit of green header strip and cut it, and done the same for yellow, red and white. I put some jumpers on the top so they'd stay spaced correctly, and then I soldered them on the back. That then means that this is colour coded without me doing any crazy amount of holding stuff and all the rest of it, or painting the connectors or any stuff like that. Now what I'm going to do is I'm going to use the purple for white and the rest just as each of the next colours. The reason this isn't colour coded, I just picked a bit of connector wire for breadboards, and I'm just using that. It makes it a little bit awkward to get these connectors on. It's not what I envisage using really, but you know what? It'll do the demonstration. So there's a bank of lead sitting on there. I added a power lead to this so I know that it's got power when it's sitting on the bench. Now what I need is I need to get this thing oriented the right way around, the purple on the top, and I'll connect that to the top bank. It's a touch fiddly. If this was a solid connector, I'd be done about 30 seconds ago, even though it didn't take 30 seconds. Okay, so I'll turn this light here off, and what you can see is I've got it set for 15-second delay at the moment. I'll bring that back to the 5-second mode. Now it won't change mode till it gets back around to the red. Then once finished this delay, it should start going at the 5-second sequence. Hello. There we go. It's not doing 5-second. I may not have plugged this header on correctly. It's pretty quick, but okay, I'll try that again. Okay. Okay, so I'll pull a different header off this time, and it should slow down markedly. So I've pulled one of the front ones off, and if I check the sheet, with the first header off and the other two on, it should be doing 90 seconds. So things have slowed down significantly now. You can't see the module in there as well, but that's okay. We know it's connected, obviously. So yeah, you can see she's gone way slow now. Now I'll plug it in to go back fast for testing mode again, and I'll turn the light on so I can see what I'm doing again. Okay, now here's another lead board. This one's got surface mount LEDs stuck on the top of it. You can see the three of them there. Now, imagine we were putting a set of traffic lights up at a crossing for people. So we've just got people walk up, they press a button, and a set of traffic lights change red, green, yellow. So what I would do is I would connect this second bank to there. This board has its own resistors and its own LEDs, and they can be the same current or different current, different resistors, doesn't matter. So there, that's connected. And there we go. The two of them are changing at the same time, which is what you would expect at a crossing, otherwise someone's going to get killed. Now, we haven't used the other bank, so imagine that this is the first. Imagine we've got these two still connected, and we're doing a T-junction that's going that way. And then I came along with the third one, which I don't have right now, and I put this on the second bank of leads. Try and get this one on without pulling the others off. Come on. Recalcitrant. There we go. Now what do we got? I'll turn the light off again so we can see what's going on. Okay, so we've got one red, and I'll put them around where they would be. So this is our T-junction. So the red light's facing one way, and there's another one that would be red out here. Come on. Okay, so this one's changing to red, and this one changes to green. So yeah, this is a pretty useful little kit. Now the time's going as it should. I probably didn't have one of those jumpers on properly. So yeah, you can see it racing through the cycle now. Okay, it could just be a loose lead on one of the jumpers. They have a little bit of copper inside them, and they push over the pin, so they can get a bit weak. So that's how it would look for a T-junction if I had a crossing. If I had a full four-way intersection, I'd have another one out here. If I had the lights as we have in Queensland, where we've got two masts in each direction, then I'd have another mast hanging off this one here, and I'd have another one hanging off it to come over to this side, and another one hanging off it to give me the one in the air. So by adding them individually, it also does something from a reliability perspective. If you've got them connected up in series and an accident befalls one of the leads or one of the leads under your layout, and it's an exhibition layout, then none of them are working and you're left with which one is broken. In this case, if one of the leads isn't working, it's not working because the leads died on the board, or there's a connection, or it can't even be a connection issue could be a connection issue with the board if there's nothing daisy chained. If there's one daisy chained and that lead is still failing, then it's going to be on the board itself. It makes isolation and fault finding a lot easier. So doing this work ready for a MERG stand that we're going to have at the Brisbane Train Show in 2019. And there's still a fair bit more work to do to get stuff together, but hopefully this gives you an idea of what the pocket money kits are and what they can do. So we said they're cheap. We said they're meant to greatly enhance your layout for very little money. So a few things to know to join the dots. MERG sells kits, but MERG sells kits only to members. That's how they operate. They have a forum, they have technical bulletins, they have 4 journals a year that get posted to you. And the forum is brilliant. There's no such thing as a silly question, and everybody's really helpful. This kit, the kit that I showed you on the diagram, rather than the one that I've messed with here, this kit costs you $6. And then for pretty much pennies, you're buying leads and resistors. So if you compare that to anything you buy commercially, this thing wins hands down. Operation of servos, it's just an amazing value proposition. I think the membership is around £20 a year for us non-UK types. MERG is a worldwide organisation, and yeah, there's a lot of members all around the world now. Okay, hopefully this has shown you what you get with the Pocket Money Kit number 9, how I've modified it, and you may choose to modify it in part in this way. And thank you very much. It's just started raining like crazy, so that'll be added noise on this video. Thank you. Bye-bye.